So, hi everyone. Thanks for the welcome. This is Ram from LinkedIn. Hope you're all doing great. Short intro about me. I've been working with LinkedIn as software engineer for over a year and a half. Today, I'm here to talk on behalf of LinkedIn's Trino team about our recent experience of Trino upgrade process, where we did an upgrade from version 352 to version 406, which is like 50 plus version upgrade and the challenges involved in doing such an upgrade at a scale of LinkedIn, where we process hundreds of petabytes per day and run millions of queries each day. So the main point of the talk would be the kind of challenges that were hindering doing frequent Reno upgrades and how we address these challenges in terms of how we dealt with breaking changes, backward incompatible changes, working with clients to migrate them off from old version, and automation of functional integration testing, perf evaluation, and how we brought down the timeline of doing an upgrade, which would enable us in doing frequent upgrades. So first of all, what is the motivation behind trying to do frequent Reno upgrades? The first point is that Reno OSS is fast-paced, releasing changes on a weekly basis, and it is very important to stay current and maintain a deep context, and also not miss out on great feature additions, perf improvements, and numerous fixes and updates to existing connectors and the new connectors. And we wanted to be in a place where we can do at least one Reno version upgrade every quarter, and that is the main driving force behind it. So, what are the challenges in doing frequent Reno upgrades? The foremost challenges that the latest versions can bring in a number of breaking and backward incompatible changes, some of which you can analyze and collect before doing an upgrade by going over the release notes, while there might be others that get exposed when we start wrapping up the production queries. To highlight how a simple behavioral change can have a major impact is that while upgrading to version 406, there was a change in casting behavior of double to varchar, which now returns a scientific format, but that was not the case in version 352. And when we switched to version 406, the sales team report started breaking because the report was not expecting scientific notation and was not designed to handle it. So such breaking changes require careful resolution and working with clients and users to migrate them to new behavior. And another challenge is that we have at least 50 plus significant internal changes that are specific to LinkedIn infrastructure that has to be applied on top of the latest Trino and other tech debt that needs to be resolved through an internal solution. So this tech debt resolution effort usually involves analyzing the relevancy and the compatibility of these patches with the new version, and a lot of refactoring, rebase, and conflict change management. On top of this, the lack of automated test framework to continuously report performance results in Trino is also a big productivity burn, since it is extremely hard to backtrace the performance issues after many commits, especially during upgrade efforts that bring in tons of changes from OSS. So Trino does have extensive testing in open source repo, but for LinkedIn internal features, we only have a very limited amount of automated testing. Especially lacking are the end-to-end testing with internal plugins and external components like Hive Metastore and HDFS. And a lot of manual effort is required today between committing changes and deploying these changes to production. So all these challenges get amplified when the upgrade is done at a scale of LinkedIn. As you can see, we have around 10 plus clusters, 4K workers, and we process 1 exabyte every month and process around 20 million queries per month. And we have at least 2.5K daily active users. On top of this, we have at least 5 plus Trino related repos, which means that if you do an version upgrade in Trino, you have to migrate these repos to be compatible with the new version as well. So this requires significant functional and perf testing and gradual ramp up to the production clusters. Because of these complications involved, it usually takes around 4 to 5 months with one dev to complete Trino upgrade and roll out to production. So how did we address these challenges? So we addressed them in two parts. We developed a fully automated pre and post commit integration testing, running on automation infrastructure called Ground Dog Day for all Trino related repositories, and then an automated performance benchmark framework to continuously report performance results in Trino, which automates the performance validation of new releases and reduces the time to release Trino changes to production. You will see about these components in detail. Here you can see how these two components are integrated in the flow. So when a Trino PR is published, when a developer publishes a Trino PR, it goes through a pre-commit integration test, and which has to pass to merge the PR. And once the PR is merged, it goes through another round of post-commit integration test. This is required because there could be other PRs that might have been merged between the pre-commit test and the merging of the PR. So the post-commit is absolutely necessary here. And once the post-commit succeeds, a Trino release is published in the artifact repository, which then is identified by the automated deployment and deploys it in the perf cluster. The perf benchmark then kicks in and runs the bunch of benchmark queries and benchmark test suits and generates a benchmark report. And once the perf turns green, we have utmost confidence to deploy it to production. So let's go over these components in detail. So the automated integration testing. So this automation framework allows creation of arbitrary scalable environment and test new changes in isolated, safe, and ephemeral way without compromising production cluster availability. So as I said, this automates pre and post commit integration testing, and it runs on Groundhog Day, which is an LinkedIn's CA automation infrastructure dedicated to end-to-end integration testing. And it uses Kubernetes to spin up a mini grid cluster, which mimics production clusters and executes a defined integration test and returns test reports. So before looking at how this framework helps in upgrade process, let's quickly go over Groundhog Day. So Groundhog Day is LinkedIn's Hadoop CI infrastructure, and it spins up ephemeral grid clusters on Kubernetes. It enables platform owners and its customers to provision Hadoop clusters on demand, whether from a development box or through automated CI. And it provides the capability to replicate customizable production-like runtime environments. Some of the important features of GST are that when a Groundhog Day spins up clusters for integration testing, it not only creates the cluster defined by the service owner, but also other services essential to running end-to-end CI test. In Trino case, it deploys Trino along with services like Hive Metastore and HDFS so that we can do end-to-end testing. And it's also ephemeral in design, which means it provisions Hadoop cluster on the fly, and they'll be recycled after a fixed point of time. This is great for writing integration tests, as users don't need to worry about dangling test state when writing CI test. And this helps in testing new changes in safe and isolated environment. And as I said, the Groundhog clusters are also isolated and self-contained, which means that the CI tests can be triggered by multiple sources at the same time, and one test instance doesn't affect the result of other test instances. So how does the Groundhog Day and this automation integration framework help upgrade process? So the main thing is that it catches issues during pre and post commit test, which means because of inter-platform dependency, unit test won't be able to catch all issues, and we heavily rely on post commit for release testing and discover issue when the change is deployed on a staging cluster. However, after this automated integration testing, every post and pre-commit to Trino automatically triggers integration test on Groundhog Day platform. And with the Groundhog Day, developers can now discover issue before merging the code, and it will give developers more confidence to deploy the application and improve the productivity. So the table on the left lists some of the integration tests written for various scenarios. The table and schema DDL has tests related to the DDL operations, while table DML has tests related to partition and partition data sets, and that's all the DML manipulation and operations. We also have one for UDF workflow, which has integration test for all the UDFs defined. And the breaking change has test related to breaking changes identified during the upgrade. And we keep adding more cases as and when we identify breaking changes in the release notes. So this helps in making sure that the breaking changes does not end up affecting different workloads. We also have test suits for every internal plugin used. A successful run of all these tests would give us a confidence to merge the code and deploy them to production as these tests run on production like clusters. And this is especially useful during upgrade of Trino, since it brings in tons of new changes, and these tests make sure the new changes are compatible with the internal plugins and internal changes related to LinkedIn infra. And this eliminates the possibility of a buggy code or a new component potentially leaving the environment in an unhealthy state and bring the cluster down. And moving on to automated performance benchmark. Automated performance benchmark framework have been developed to continuously report performance results in Trino. It automates the performance validation of new releases and reduces the time to release Trino changes to production. And it also standardizes the performance validation for Trino with representative queries from various workloads and users. So the perf benchmark has three components: a benchmark execution code module, and a set of SQL queries called test suits, and a report generation. And the highlights are that it allows us to define and store benchmark test suits. And test suits are basically a set of Trino queries, and you can also configure the repetition and job concurrency of the test suit. These parameters are useful if you want to simulate a load test similar to production traffic. And you can, if you look at the left, we have the job concurrency and the repetition count, and you can configure the concurrent the amount of concurrency that you need and the repetition count to mimic production traffic. So coming back to test suite, apart from TPCH data, we have test suites that are queries sampled from production pertaining to a different workload. And even though we have TPCH data for perf testing, it was important and necessary to add production queries, since they would be representative of the use cases and the type of queries being submitted. And the perf runs would be able to catch perf regression on a particular to a workload. The benchmark also allows you to create validation rules. A validation rule is a threshold rule that can be defined against any benchmark metrics like execution time, wall time, CPU time, or memory, or failure rates. And the benchmark would fail when the defined validation rules are breached. If you go back to the left job, so here you can see that the test Y has two metric thresholds set. One of them being the elapsed time average being set to 10,000, which means even if the test Y succeeds, but if the execution time is more than 10,000, which this would still fail because this is clearly a perf regression for this test. All these numbers are computed based on a careful analysis of the production traffic. So this would help in this validation rule would help in automated perf examination of the benchmark results, and you can define the validation rule on many metrics, and this would help in analyzing the performance runs of each queries. The perf benchmark also generates a benchmark report at the end, and it allows scheduling benchmarks to run at a fixed interval. The main advantage is that it gives you the ability to see a trend of important perf metrics for Trino and dependencies like HMS, Hive Metastore, and HDFS. So here are some of the perf incidents that we faced during upgrade to version 406 caught by the perf benchmark, and it validates the need for perf benchmark. So the first one is that there's a system table query regression, So with 406, we noticed that the system table queries took more execution time because of the T-digest histogram metrics that were added, which are quite CPU intensive. So usually the system table queries are lightweight, but because of the T-digest histogram metric overhead, the execution time moved from milliseconds to seconds. And this led to a loss of metrics on our side because we had a lot of internal jobs that were querying system table queries to emit metrics, and this in turn led to loss of alerts. So this scenario also validates the need for having representative queries, as this perf regression is specific to system table queries, and without having such representative queries, this would have been caught only in production. The second incident is because of auto scaling of writers enabled in 406, the queries got slower. So when writer scaling is disabled, it spins up a fixed number of writers. But when we enable it, it starts with one writer and then slowly adds more based on a threshold. So because of this change, the scaling of writers, especially on unpartitioned data sets, was low, and hence the queries were struck for 2+ hours. And the speed at which it was scaling probably needs to be fine-tuned or a scope for improvement. And this is just a config change, and this highlights a scenario where you can run perf benchmark to run against different configs and see the impact and decide which config would be better applicable for different use cases. And the last incident is query slowness due to local scheduling. Basically, due to local scheduling, a worker node can have a large number of splits compared to other workers. And on checking further, we confirm this is because of local scheduling optimizer being enabled in version 406, because of which if the worker and IP and the HDFS IP is same, the split gets scheduled there. But that what happens is that because one of the workers can have more splits to process, it becomes slower than other workers and becomes a long tail. So these are some of the incidents that highlights the need for automated perf benchmark that can proactively capture issues and perf regressions and enable us to diagnose and fix them before hitting production. So after these, what is the state of Trino upgrade process after these foundational things being built? So right now we have a quicker integration of open source changes. We have proactive capturing of breaking and backward incompatible changes, and also shorter mean time to detect and resolve perf and functional regressions. And because of the automation of the integration and perf benchmark, which keeps churning integration benchmark reports, as and when new changes are merged. This helps in quicker detection of which change caused the regression and quicker integration of the changes. And all of these combined has reduced our upgrade time to 1 month, which was used to be 4 to 5 months with a single developer. I know I'm short on time, so a quick update on future work is that we are trying to automate the upgrade process now so that we can keep up to date with Trino open source, and which would help us in merging daily changes from Trino open source, and with all these foundational framework being available, we would be able to merge them with a successful integration performance test. And if it fails, the on-call get alerted and work on it. So this would enable us in doing upgrade every other week with minimal to little effort. So that is it from us at LinkedIn, and I hope this talk helps you in your own Trino upgrade effort and brings down the toil and the manual effort needed to complete the upgrade. Thank you.